last tutorial we looked at, we demystified a transaction and saw the different kinds of transactions. So right now we'll be looking at the different kinds of scripts that we have. We have the PubKey hash, we have the wrapped SegWit, we have the native SegWit, and we have to pay to taproot. So we'll be going through one by one and understand the intermediate steps. But now what I'll be looking at is scripts that are sending to each other. So if it is the legacy one, legacy to legacy. If it's the wrapped, if it's the native to native, if it is the taproot to taproot. Yeah, so we'll be determining both the output and the input using the same recipient and sender type. Yeah, so I think we can get started. So I'll be demonstrating using very simple scripts, Python scripts that I have created so that you can look at the steps. So first of all, we'll be looking at the PubKey hash. This is Pay-to-PubKey-Hash, that is. So right now I have some legacy addresses that I've generated. Yeah, so currently what I just did, I just created a wallet and then gotten some test bitcoins from the faucet. Yeah, and then loaded them in a legacy address. So currently the address with the test bitcoin is this one. So now I'll be sending the test bitcoin to another address that is any of them. So I'll be sending to any of them so that we can see how we can validate the scripts. That is the authorization steps. Yeah. Yeah, so we understand that the output script of Pay-to-PubKey-Hash is this one. So we'll be looking from the transactions that we'll be getting. So first things first, I will just look at the balance of my wallet. So you can do this, or you can even get the wallet info like this. So currently this is my balance. I think it will be enough for demonstration purposes. So the first thing that I'll do, I'll just use the legacy addresses to send some test bitcoin so that we can see both the output and the input scripts. So this time I'll be sending to this legacy address. I'll be sending to that legacy address, and then I'll be setting the amount to be equal to this amount over here, to our balance. I just want to use a single output and single input so that it can be a bit easier. So now I'm subtracting the fee amount from this amount that I'm sending. So I'm sending the entire unspent. Yeah, so invalid bitcoin address. Okay, so I'm taking the transaction ID. So this is the legacy address. This is the legacy address. So okay, so now this is the transaction ID. And this is a legacy transaction ID. So this is a legacy to legacy transaction ID. So you can see it by getting the transaction. So I'll just use get transaction. Okay, let me just type it manually. Get transaction, and then so this is the entire transaction, as you can see. So this is the script, this is the output script, that is the output script. So now this is the PubKey hash that will be working with. So now I can just look at the previous transaction that I made. I can just look at the previous transaction that I made. I think it is this one, the transaction ID ending with EB. Yeah, this is the transaction ID that is ending with EB. This being the out point. So now this is the out point. We can just look at this transaction and see how it looks like. And see how it looks like. I'm so sure it has a single output. So this is now the single output that this latest transaction is consuming. Yeah, so this is the output that it is consuming. So we'll be looking against this PubKey hash. So I can just copy paste it to our simulator. So this is the PubKey hash. So now let us look at our current transactions. Okay, so this is our current transaction. As you can see, pointing to this, the index is 0. And now you can see this is the signature with the Ccash flag, and this is the primary key. So we can just copy the primary key here. To our processes. So I'll take this one. But instead of all is just a flag to show that it is for all inputs and all outputs. So instead of 98, I'll just add 01. That is what it means. Yeah, and now we can go ahead and check how it works. So the first step, we are pushing the signature. So this is the entire thing. So we are just taking this one, as you can see, for our out point, the previous transaction over here, 442. Yeah, we are just taking that one, and then we are appending our input script in our current, which is the latest, consuming that output. So this is the vin, the vector input. So this first part is the signature. This second part is the public key. Yeah, so this public key is the one that we are using to look at the PubKey hash that is in the previous transaction. So this is the output that we are currently trying to consume, to spend, that is. Yeah, so we'll be looking at it. So let me just set a breakpoint and see how it goes. So I'll just start by debugging in debug mode. Okay, so this is the entire script. So the first step is pushing the signature. Now you can see the stack as the signature. This is the one that you're pushing. And then next, step 2, we are pushing the public key. This is this public key over here. The public key inside our current transaction that is pending the UTXO, the previous transaction here. And then as we continue, so now this step we are duplicating. So this is the entire script. So right now we are here. So this optcode, what it does, it pops the pub key, duplicates it. Okay, so as you can see, it has just duplicated. So we have two similar pub keys over here because of the duplicates. So the next one is applying the hash 160. So it pops the top pub key and then performs the hash 160. And then after that, it pushes it back into the stack, as we will see. So right now, you can see it has popped the pub key and then used the hash 160 and then pushed it back into the stack. So next, now we are pushing this output script, into the stack. So this one is from the out point of the previous transaction, as we saw. So now you can see the stack. Now you can see the stack, how it looks like. And then now the next step, okay, so the next step, it popped the two items and then it is now checking if they are equal, as we can see in step H, and then we'll get the results. Okay, so they are equal. Now printing the stack. Now we are left with just the operand that the checksig should work with, that is this public key and this signature. So this is the Pay-to-PubKey-Hash, as you can see. So this first part over here is the output script that we are trying to consume. So when a transaction is made, so this is the out point. As you can see, V in, this is the out point. And this out point is for this transaction, the previous transaction over here. Yeah, and this is the previous transaction. So it is same as this part. So that is this part over here. And then now we are prepending now the signature and the public key. So this is the input of the current transaction. So this input should be able to satisfy this output. So it is like the key to this lock. Yeah, so now that is the pay to PubKey hash. I hope you understood.